welcome back, or welcome back if you caught our earlier sessions. And if this is your first session, a huge big welcome to Wilderness Labs DevCamp, where we're going to learn all about using C# and .NET to build hardware solutions. And in this session, I'm going to be talking to you about something called Meadow Foundation. And before I jump into it, I should probably introduce myself. My name is Adrian Stevens, and I'm a dev advocate here. Now, in our previous session, we talked a lot about Meadow, the Meadow board itself, and specifically we got our system and our hardware set up for app development on Meadow. We made sure we're running the latest version of Meadow OS, we set up our dev environments on both Windows and Mac, and we deployed an application. And we looked a little bit at the C#, we saw that the code was using some common C# patterns, but didn't go too far into the API surface, and that's what this talk is all about. And specifically, we're going to use something called Meadow Foundation. But before I get to that, I want to talk just a little bit about prototyping. And often when we think about hardware development, we think about prototyping. And in the software world, you might go build a simple application. Well, it turns out that there's actually a lot of parallels. Here, we can actually build a simple hardware configuration and build a simple hardware solution. And what's really fantastic about Meadow is we are using off-the-shelf open hardware. And that means that we can prototype on our Meadow F7 board, and then we can use that as a path to production or even commercialization. We like to say, hey, same hardware, same code for our prototype and our production hardware, our production deployment. And later on in other sessions, you'll even see some techniques for building enclosures and even creating custom circuit boards to support those kinds of things. But here, we're going to talk about Meadow Foundation. And this is something that I'm really passionate about. I'm a C# guy, and I love that we've got C# .NET APIs that can enable even people that are maybe new to hardware to rapidly build prototypes. And I'm going to show you a few techniques and show you some of this API surface here today. I also want to mention we have something called the Wilderness Labs, the Meadow Hack Kit, which has a bunch of really great hardware. And I'm going to try and use some of the hardware from this hack kit. But and of course, Meadow Foundation supports the hardware in the kit, but we do support things beyond that as well. So yeah, we'll use the display from the hack kit, we'll use our push button, and then we'll use a couple of things that you might be able to buy from other sources as well. So enough talk, let's get into it. Let's dive into Meadow Foundation. So let's switch over to Visual Studio, and perfect, good, my Meadow is on screen as well. So I've got a Meadow board here mounted to a wooden baseboard alongside a white prototyping board. And I've done a little bit of pre-work here. I've added some jumper wires to connect the Meadow to the prototyping board. And we've done this because we're going to use these jumper wires to connect hardware to our Meadow board. And I want to pre-connect this so one, you didn't have to watch me fiddling with the wires, and also hopefully to avoid any wiring mistakes. Now, I also have a brand new Meadow application here in Visual Studio 2019. This is just the file new experience. So this is flashing the onboard RGB LED, same project we saw in the previous session, and that application is running on our Meadow board right now. Pretty fantastic. We've learned that we can use our C# skills to control the onboard RGB LED, but what if we wanted to get some input? What if we wanted to get some user input and read that in our Meadow application? Well, just so happens, look, we have a button wired up to our Meadow solution, and I think now is actually a really good time to talk just a little bit about some of the wiring here. So I'm going to angle the board up, and I want to draw your attention over to these jumper wires here. Now, this might not be easy to see, but this yellow wire here is connected to our 3.3 volt source, the 3.3 volt pin on Meadow. And that's running into this positive power bus. So see what this red plus is? Well, all of the pins, all the holes across this row here are connected. So when this pin comes to the 3.3 volt rail or bus supply, it will power all of these pins. That gives us a power bus, a 3.3 bus. Same thing with this orange jumper here. That's to our ground, and that's actually connected to the minus or the negative or a ground bus. So now we actually have a power bus. We've got our 3.3 volt and our ground, and that's going to allow our peripherals to tie into the power supply of our Meadow board. And that's actually quite important for our button because we've done a little bit of clever wiring here. So first, if we look at our button, notice it up here. So if we follow it down, notice there's a resistor here, and that resistor is connected to ground. Now, just below it, and again, I'm not sure if this is super easy to see in the camera, but this jumper wire, this long jumper wire here is connected to the same column of pins as the resistor. And so what that means is these are all connected, and so that resistor is connected to this jumper wire, and they're all both connected to ground. And so what that means is that in the default state, this whole lead, this whole jumper wire is set to ground. And so we're actually pulling this pin down to ground, and that's pin D12. Now over here, when we push the button, it's actually going to connect across the points. And what's that connected to? Well, this jumper here is actually connected to the power, so that's going to actually raise this up to 3.3 volts. And the reason we have the resistor here is so we don't short it out power through ground. So this kind of slows the current. So when we hit the button, we're going to connect it to the power, the 3.3 volt. It's going to both go through the resistor, but also to the pin, but more power is going to go to the pin because there isn't a resistor over there. And this is called a pull-down resistor. And this is actually a common way of wiring up buttons. And it turns out you can actually use internal resistors in Meadow, so you won't have to do all this wiring, but it's kind of a fun thing to look at. So how would we use it? Well, Meadow, we represent the pins internally, the digital pins, as we call them ports. And so I'm going to create in our code an digital input port. And for now, we're just going to call this buttons because it's going to be connected to our button, but really it's going to represent pin D12. And let's scroll down to our initialize method. So remember from the previous session, this is where we initialized our RGB LED. And let's also initialize our button. So to create an instance of our digital input port, we're going to use that device property. And if you remember from the previous session, the device property comes in. It's part of our app base class, and it's actually defined by this F7 micro class. And so the F7 micro class knows the shape of the Meadow hardware, and so it knows how to talk to all the ports, all the pins on this particular hardware configuration, which is very important. And so we're going to call create digital input port, it's like a factory method, and the first thing it's going to ask for is a pin. Now I just said that the device class knows all the pins and actually has a pins property, and I can actually specify pin D12. And of course it has representation of all the pins on this particular board. If we had other hardware form factors in the future, we would have a different hardware definition class. Now here's where things get interesting. So the pin, that's pretty straightforward. We've connected to that pin, but now it wants an interrupt mode. And so for that, that's going to say, well, yeah, we actually want to know when things happen. And i.e., we want to be able to detect button presses. We'll actually use that through an event, which you'll see in just a second. But notice we have all these choices. We can do edge both, edge falling, edge rising, and what this really means is detect when the signal changes. As we said, we're pulling it to ground through that resistor, our pull-down resistor, and then when we push the button, it gets raised up to 3.3 volts. So we can detect when it's raising, or we can detect when it's already hit our high voltage and starts falling, or both, or when it's actually a steady state level high. I'm going to use edge rising. That's nice and responsive as it's going up. We're going to catch it. And the resistor mode. So as I mentioned, we can use internal resistors. This is going to work really nicely in the next release of Meadow. For now, we're using our external resistor. Now, this is actually slightly complex intentionally, and I'm going to show you that in just a second. But there's something really powerful I also want to show you, and that's that because we've set that interrupt mode, we're able to detect changes on the button, or on that port, I should say. And there's actually a changed event, and I can wire this up by creating a button change event. And let's hit apply there, and let's just do a console write line, detect it, button pressed. So I'm going to deploy this application and then talk a little bit about it. So notice, again, this was actually a little bit complicated, and it's because we're using the lower level port APIs. These are the lower level Meadow APIs, and these give us a lot of fine-grained controls. If you see, we have really good control over how we're notified when that port state changes. And very cool that we can subscribe to events and respond to them, so pretty fantastic. But we just want a button press, really like something simple. And this is where Meadow Foundation comes in. And Meadow Foundation is going to give us types that actually wrap up some of these lower level APIs and make it a lot easier to consume and interact with hardware. But there's something else really cool I want to show you. So remember from the previous session that we were running that cycle colors method. And of course it's ongoing and actually has a thread sleep. It's actually sort of blocking, right? But because we're event-driven here, this is modern C#, I'm going to push this button. And notice in the output, we see our button pressed. And let me just do that a second time. And again, it's working. So event-driven, it's happening while the LED is changing. Pretty cool. So let's do something else. And I want to add a sensor. I want to get some data from the world around us. So user input is great. We've got a button here. We could have switches. There's things like potentiometers to detect rotation. Rotary encoders are a really cool type of interface that will detect fine-grained clicks and turns, all types of things. But we also sometimes want to read the environment around us, and atmospheric sensors are great for that. Just so happens that I have one here. This is the type of BMP 180. I'll show that there, and I'm just going to throw it down. I'm going to leave it up here for the moment. Have a look at it. So hopefully you can see it has 4 pins on it, but how the heck do we know how to hook it up? Well, turns out most of these things are very well documented, and for the BMP 180, we could go look at a spec sheet. And it just so happens I have the data sheet for the BMP 180 in front of me. And let's have a look. Okay, this is 28 pages. So I can start scrolling through and so we get some specs of the hardware. I keep scrolling through, and wow, this is actually a lot of stuff in here. And this is very common for this type of hardware, where the spec sheets are very, very detailed. But it takes a bit of a fine eye, and it takes a little bit of practice experience to dissect them and understand them to a level where we're able to use them. And also, this is actually kind of interesting here as well, where it's talking about the actual chip and not necessarily even the breakout board here. So we have to have an understanding of the actual how it's manufactured on that little board as well. And this is all feeling very complicated. Now, I'm going to be honest with you. If you can write C# code, I'm confident that you'll be able to go through the spec sheets. Yes, they're technical. Yes, there's lots of numbers and pages. But give it enough time. I guarantee you can go through and digest this. But the question is, do you want to? And I'll just show you, if we go through here a little bit more, you can start getting more details on the pins and the calibrations. And these are full of really good information. And it is very important to know these are here. And if you need specific information about the hardware, great to know these exist. But generally speaking, you just want to know how to wire it up and how to get data from this device. And that's if we head on over to the Wilderness Labs website. You're not surprised by this. Make sure we can see everything okay. And so here I pull up the documentation for the BMP 180. And it turns out that we already have, Wilderness Labs has a driver specifically written to work with this piece of hardware. How cool is that? Now you might still be thinking, that's great, but I still don't know how to use it. I don't even know how to hook it up. Aha, got you covered. Most, if not all of our drivers will have what we call a wiring diagram, or a fritzing diagram, it's often they're referred to, and it shows you how to wire this up. And so we need to have a positive voltage, that's the 3.3 voltage. You can see actually this looks a lot like how our board's wired. We've got a line running from our 3.3, a line running from our ground, and we want to make sure those are lined up. And then these 2 lines here, and this actually says SCL, which is clock, and SDA, which is our data line. And so this type of bus it's using is called I2C, and it needs 2 wires. Now, you're not too surprised here. I've pre-wired this to make life easy, and I've even put it all in the right spot. But if I hadn't, I could come to the Wilderness Labs website and look this up. All right, great. We plugged it in, but how the heck do we use it? Well, let's go back to Visual Studio and find out. All right, so what I was actually looking at was the documentation for Meadow Foundation. And Meadow Foundation is a collection of drivers that are distributed. There are open source, of course, and they're also distributed as Nuget packages. Because, hey, we're modern C# developers. So I'm going to right-click. I'm going to hit Manage Nuget Packages. And I am going to search for BMP 180. Now, it's a good idea to often prefix with Wilderness Labs or Meadow, but in this case here, look at that right at the top. Meadow.Foundation, sensors atmospheric BMP 180. Now, how great is this? I'm going to bring in a driver specifically written for this sensor. It's going to allow me to rapidly pull in data. So let's go back to the code. And let's instantiate it. So we'll go up top here, and the first thing we need to do is create a BMP 180 reference that will turn to an object, and I'm just going to call this sensor for now. You can also call it BMP180. Now, of course, it doesn't recognize the namespace yet, so let's start, or the type. So I'm going to right-click using Meadow Foundation sensors atmospheric. So all of our sensors are organized into nice, tidy namespaces. But just like that, add a Nuget package, created an instance. And now let's instantiate. So keep in mind this button, right? We instantiated our port, a little bit complicated. Let's try this now for our sensor. Sensor equals, so C#, let's just instantiate BMP180. Now this needs something called an I2C bus. And so our Meadow Foundation has this bus that is on our pins D7 and D8. And if you want to validate that, we can hop on over to our website again, and there's pinouts. So if we go to Meadow.io basics, you can see our pinout. And notice I2C over here, clock and data line. So our clock is pin D8, our data line is D7. Already wired properly. And again, you can validate that by looking at the documentation. So here we just need an instance of this bus. And so I go device dot create I2C bus. And I can set frequencies and the speed, but I'm going to leave the default values for now, because that's great for this. And then the next parameter we need is a bus. It's an address, I should say. And this is a I2C convention, and it helps and aids the I2 bus in communicating with this exact peripheral. Without going into too much detail, the reason for that is you can actually put multiple devices on the same bus and they're accessed via their address. But notice, if you can see here, it's pre-populated in the constructor. I don't even have to know it. So I'm just going to close that off. So here's our sensor. So notice that. So I've just added a very complicated atmospheric sensor that can read temperature and pressure data, and it's less work than wiring up our interrupt port to read a button. And this is the magic of Meadow Foundation. If you get nothing else this presentation, this is the key moment. But, of course, we can do a little bit more with this. So I'm going to do a quick little bit of wiring. So again, we're be event-driven. So I'm going to go sensor.updated. So much like our change event, we're going to subscribe to the updated event, sensor updated, and I also need to call sensor.start updating. And let's do another console write line here. So console write line, and let's do some modern C#, $ quote, and so now I should show you here that it auto-populated our sensor updated, and it passes an atmospheric condition change result. It's a little bit of a mouthful, but actually pretty straightforward. If I hit E dot, and notice I can go new, the latest value, and I can get our temperature. And we'll do the same thing for our humidity. Now I'm going to cheat just a little bit. I'm going to do a little copy paste. I like to format this, and I want to get our nice tidy degree symbol. So I'll grab that from my other screen, and I'm going to put this here. This is degrees Celsius, and I believe this is in pascals. Let's see if we can get that correct. Close that quote, close the paren, semicolon, turn off the insert. Let's deploy this again and talk about what we just did. So again, pretty fantastic. Created our instance, subscribed to the event, told it to start updating, and let's see what happens. Now, if you're able to spot the output, you may have even seen it write the BMP180 DLL, and that, of course, came from our Nuget package. And let's see how we did here. And so we are reading a temperature value. So I made a silly mistake. I grabbed a humidity value, and this, of course, should be pressure. We'll fix that in the next release. So a lot of these atmospheric sensors will have temperature, pressure, and humidity. This particular one does not read humidity, so it just returns a 0 result. Let's fix that now before I forget. We'll change that to pressure. And but I will show you the temperature is working. I put my finger on it, and notice it goes up. So really cool. We've now got a button firing events. We've got a temperature sensor firing events and updating. Pretty cool. Now, if we weren't sure how to do this little bit, we were still learning Meadow Foundation, well, heck, we're going to go back to the website. Going to go back to our documentation, and notice here, we've got some really fantastic sample code. And I'm going to show you something else. So I did this the really simplistic way, but there's actually a much more powerful way to get data from this device. And this is using an eye observable pattern. And this is going to allow us to filter on the data coming back, do some fun things like averaging the values and whatnot. And this is a really powerful pattern. I did the quick, maybe less powerful way today for the purpose of this demonstration, but this is a really cool way to do this, and this is a really fun pattern to absorb. And if you're familiar with eye observable, you probably went, oh, I can't wait to try that. We'll keep it really light and simple today. Okay, so that was fun. That's cool. Got some temperature values, but let's see if we can't do something a little bit more interesting. And I'm going to show you one of my favorite things in Meadow Foundation, and that's hooking up displays. And so it just so happens I have the display. Let's see if I can put this in. This is the ST7789 display. This is the one that is included in the hack kit. Now this uses a different style of communication. So our atmospheric sensor, our BMP180, uses the I2C bus, and this guy uses something called the SPI bus, which is sometimes referred to as a 4-wire bus. Now, I'm not going to go through all of the details of how this works, but I will show you again. We've got a ground and a power line, and then we hook up a number of these data lines. And I'll just show you. So these 3 pins here, there's an SCK, a Meso, and a Mosey pin. So those are the 3 primary pins for this bus. Now the clock is actually, it's the clock. It triggers when the data is transferred against an SPI device. And so what that really lets us do is lets Meadow control the speed. So Meadow controls that clock, and it dictates how fast data goes back and forth. And then there's 2 pins, one's output and input. So the old way of saying it is master out, slave in. I'm going to change that to Meadow out, SPI peripheral in. So our Meadow out pin is what we need to send data to our display, and then you'll notice that we're actually not using the Meadow in pin, the Meso pin. And that's because we don't need to read data from the display. But if we had an SPI device that was sending data, so maybe we had another sensor, maybe we had an accelerometer or a different type of atmospheric sensor, or motion sensor that used the SPI bus, well then it would be sending data to Meadow. Okay, great, go with display. And so I could do the same thing where I could pull up the spec sheet and show you that it's actually a really enormous dock. And you're not be surprised to hear that, hey, we've got an API for this one as well. And so to do this, we're going to add another Nuget package. It's gonna browse. Now, in this case, you might be thinking, hey, let's search for ST7789. This one's actually a little bit different. I'm gonna search for TST-SPI. It's because there's a common driver that supports a number of these TFT SPI displays, because it turns out that actually a lot of these displays have very similar interaction under the hood. So they're actually the controller boards have very similar characteristics and behaviors. And so we wrap this up into one tidy driver, and this is pretty great. And I'll just show you, I've got another driver here that's it's a different shape, but similar in style, and it also has many pins. And again, it would be wired up very, very similarly, and you just have to make sure you're using the right driver for the right controller board. And most of the time, if you flip them over and look at the back, you can find out exactly which controller board you'd use. Okay, great, Nuget package. Let's go set up our application. Same thing, we'll come atop here. ST7789 display. We'll go in and fix the using statement, our namespace. Meadow Foundation displays TFT. No surprises there. Now this one requires just a little bit of work to set up, and I'm actually going to bump this here. Let's go button and BMP180 and display. Now, just like we could for the other sensors, I would recommend this is a great example where you go to the website and do a little copy-paste for instantiation for setup. I happen to have it on my other display here, so I'm going to do a little copy-paste myself. But I'm going to show you another way to get some information here. So I'm going to grab the constructor, bring this in. Again, C#, instantiate ST7789. Very common here again. You see they take these device parameters, and that's to let it interact with this exact Meadow board. Pretty fantastic. And the one thing we're missing here is the SPI bus instance. And just like we did with I2C, we could use a device, where is it here? We can device factory method to create the SPI bus. And this one we're going to do it a little bit differently because there's a tiny bit more configuration we need to do here. So device.create SPI bus, and then we specify the pins. And I showed those to you earlier. We had the clock pin, the MOSI, the Meadow out, SPI peripheral in, and the MISO, the Meadow in pin. Now, in this case, we're doing something a little bit different as well. And this is actually a cool example. And so SPI has 4 different configurations. They're known as modes 0 through 3. And for the most part, when you're using these drivers, you don't have to worry about these too much, but it's a good idea to look at the sample code. And this particular display is an interesting one because it's usually mode 3. But for this driver, for this ST7789 controller board, every once in a while you will find one that comes out as mode 0. So if you have one of these that's not working, try change the modes. If you're using the display in the hack kit, this is the code to use, and this is the exact code you're going to find on the website. Great. And you can go through here. There's a couple of other pins we use. One is it's a reset pin, very common. I'm going to be honest. I think under the hood, this pin's not even used on this particular driver. Sometimes they're used for initialization. And then there's some data control pins, and those are used for the display driver, for example, to change between where it's accessing and reading data and what that data is. So you say, hey, write to this address, and then you toggle that pin, and you know, here's the data. And again, you can go look at the drivers because they're all open source if you want to know a little bit more. But the cool thing is you don't have to. It's Meadow Foundation. So let's write a little bit of code, and let's make a new method here. I'm going to stop using cycle colors, and let's do update display. And I'm going to put this right here for now, void update display. Now I'm going to show you some common patterns of using displays with Meadow. So display.clear, well, lets you clear the screen. I'm just going to see, okay, I've got a clear screen method here as well. We'll use just clear for now. And then let's just draw some pixels. So if you notice the display object, there is a number of helper methods here. There's a draw pixel. We'll use this one for now. And let's do for int I equals 0, I is less than I. Let's do 50 pixels. Let's do 60, I++. And we go display, draw pixel, and then it's going to take an X and Y coordinate. I'm going to use I for both of those. And then optionally, we can set a color. Let's give it something nice and bright. Let's just say, oh, sure, let's do aqua. Aqua sounds good. And last but not least, very common for lower level APIs, we force an update. So under the hood, draw pixel is actually writing to an in-memory buffer, and we need to tell it now to actually update the display. And so what's happening here, let's run the code, and then we'll talk a little bit about that. Let's deploy this here. We're calling update display, clear, draw, and show, and deploy. So the clear method is actually clearing an in-memory buffer that's created when we instantiate the display. Again, this is all done behind the scenes, so you don't have to worry too much about this. And then this draw pixel method will write data to that display buffer, that in-memory buffer that's appropriate for this display. And then when we call show, that's when it's actually going to push the data over the SPI bus, so through that MOSI pin, if you will. We'll get this moment to deploy. Now, while this is happening, you may have noticed, and actually I can play with this code a tiny bit, that there's actually not too many methods or properties here. And great, I'm going to pause. If you go look at this screen, and it looks a little bit white on camera, I think. Let's see if I angle it. It's actually a bit blue. We've drawn a line. We've drawn a pixel. And that's 50 pixels, 50 points long. But you might be going, what if I want to draw some primitives? What if I want to draw some text? And so it turns out we actually have another helper method. And the cool thing with this is this actually comes in a separate Nuget package, but I'm not going to have to update this because it actually pulled in automatically when we bring in our displays TFT SPI package. It also brings something called Meadow Foundation graphics library, and that's going to give us the ability to draw text and draw some shapes. So let's quickly wire this up, and again, you're going to use these patterns now. But there's something really powerful here. I'm just going to call this graphics. And I'm about to show you when I create this. So we're still going to use our display instance. Now we could actually tuck this away and use it as a local variable in our initialize method, but I'll leave it there for now. But I'm going to instantiate our graphics. So new graphics library. And so notice it wants a type of display base. Turns out that our ST7789 display does actually inherit from display base. And what's really cool about this, I'm going to actually pop in. I'm going to go to the definition. And this derives from display TFT SPI base, which actually has, I think, 6 drivers in it today. And if I go a little further in, there's our display base. Now, this is actually really important because all of the displays we use in Meadow Foundation today derive from display base. And so what that means is all of the display drivers in Meadow Foundation can work with graphics library. So I'm using a really cool display here, and if you've noticed yet, this is a nice high res display. It's actually 240 by 240 pixels. It's 16 bits per pixel color resolution. It actually goes up to 18. And it's only a 1.3 inch display, so actually really high pixel density. But the graphics library will work with single color displays. It'll even work with some fun displays like, I'm going to show you this guy quickly. If I have time, I'll fire this up. Maybe we can do this demo later on in the day. But this is actually a display that's composed of just arrays of LEDs, just these 8x8 arrays. This display driver also derives from display base, and that means that you can use graphics libraries to draw text and primitives on that display. So let's give this a go. And I'm going to make this move a little bit faster because I want to show you kind of some of the end results. So I'm doing just a tiny bit of copy paste here. And let's go over to our update display method, and I'm going to replace this now. So notice, now I'm no longer interacting with the display directly. We'll use the graphics library, but you're going to see a similar pattern. We're going to clear it. We're going to write to it, and then we're going to call show. So internally, this is actually going to use the same memory buffer under the hood. It's going to wire in and make sure that we're using that same memory buffer for that display. It doesn't create its own buffer. It actually just passes through. But it uses the display's draw pixel method to do all this drawing. And I almost forgot something really important, so I'm going to go fix that right now. I'm going to scroll down. And one fun feature of the graphics library is, of course, the ability to draw text. And to do that, we want to make sure that we assign a font. We are working on a lower power, lower memory device. And so we don't load all the fonts into memory. And so what we do when we draw a text is we actually assign the font. So on the graphics object, there's a current font property. And I'm going to assign it to a relatively large font. We're going to go new, and we're using a font that's actually, it's defined as a 20 by 12. That's 12 pixels wide and 20 pixels high. Now, if we look at our drawing methods here, we're calling draw text. So here I'm actually going to draw the sensor, the temperature value, like we saw earlier to the console. And I'm actually going to use something called a scale factor in our text. That's going to allow our text to be a bit larger, because we just talked about how pixel dense this display is. So we're going to just bump that up and do a multiplication, and we can go higher than 2 as well. And let's deploy, and if you're watching the output, you may have seen it write the new libraries as well. And we'll give this a moment to launch. And fingers crossed, we'll see something a little more interesting on the display. And there we go. I might change those colors, make them a little bit brighter. Let's do yellow here and maybe lawn green there. But I'm going to angle that up. It's upside down, but there you can see that we're drawing a font. There's our temperature and our pressure. Now, at the moment, it's not dynamic. So we just called update display once. Let's do a little bit more work, and we're going to make this a little bit fancier and use a few more APIs in our toolkit. So I'm going to do a little bit of copy paste now, because a lot of this it's just C#, and so this is all we're going to walk through it. And I can do one thing first. So I'm going to grab a helper class that I've just called conversions. And I like this as well because it shows you that, again, we're just using C#, and so this behaves like a .NET project. I'm going to right click. I'm going to make a new class. Here we go, a new item, class, perfect, even better. And let's call this, I just call it conversions. I'm going to make a little simple one. C# class, add it. Great. And I'm actually just going to add a couple of static methods. Really kind of quick stuff here. I can get rid of that. I copied too much. Let's get that cleaned up. Bring that back, and perfect. So won't spend too much time here, but we have a quick property, and this is the standard standard atmospheric pressure in I believe it's pascals. This is number of pascals. If I said that wrong, you can let me know in the chat, for standard atmospheric pressure. And then I've got a couple conversions for Celsius to Fahrenheit, pascals to PSI, and to millimeters of mercury. And this is just some quick conversions. We're going to make use of that in a moment to have some fun with our application. Let's go back to our Meadow app, and then I'm going to do one more quick copy paste, and then we can explore the code that I'm bringing in. This is going to allow us to do things a little bit fancier without a display, but it gives you a sense of some of the things you can accomplish with these Meadow Foundation APIs. So let's just copy this and paste this up here. And I'm going to start, and I almost missed a property. So I'm going to add a couple of properties here as well to our class. I'm going to have a little fun here. I'm going to add a bool is metric. So this sensor does output metric data, but I know we don't all use metric, so we're gonna use our button to actually toggle between metric and imperial values, have a little fun with our input, and then we're gonna fancy up our visualizations here. Now, there's something you might notice as well in this code, and it's something that's very common on Meadow today. So keeping in mind that Meadow is in beta, and we haven't completely implemented the debugging story yet. So it's very common to use console outputs to help track your progress in the application. And this is a really great technique. If something's not working right, I love the console output. And again, you're going to get a full debugging story down the road, but for now, you notice that I like to pepper these into my methods. So we saw this already. Again, we're going to clear. And now I'm just defining some local variables. We could actually probably escalate these to class level. A couple, I'm gonna, well, that's okay. They're fine there. A couple of colors, and I actually sampled these from the Meadow website, from the Wilderness Lab website. And then we've got some helper methods to format our temperature string. And the reason for that is, let's have a look. Temperature string. And I'm gonna move a little bit quick here, because again, this is just C#. But this is going to take in a Celsius value. It's going to check our ismetric boolean. And then if it's ismetric, then we're good. We'll just do a quick string formatting. Otherwise, we'll use our conversion helper, our method there, our helper class. And they are static Celsius to Fahrenheit. Again, this is just C#. This is actually pretty boring stuff. This is stuff that, hey, I bet a lot of you already know. And again, think of this. We're just in Visual Studio right in C#. This is all pretty comfort zone. And I actually even hope you're sitting there going, I might structure that better or move things around. Because you can, because it's C#, it's Visual Studio. I'm doing this in kind of a quick way to show it off. And let's just have a quick look at some of the APIs here. So previously, we saw on our screen, we're drawing some text, which is pretty great. Now let's pre it up. I'm going to draw a circle, give our temperature a little border. I'm going to get rid of the temperature labeling and just put the Celsius value or the temperature value. Same thing for pressure. We're going to draw a bar, draw some rectangles. Now, again, there's some hard-coded values here. And again, this is just for a quick presentation. But you could, of course, do some fun things like make these dynamic. Maybe read the width and height of the screen and make it responsive to other display sizes. But I wanted to give you a quick sense of some of the things you can do here. And before I forget, let's just wire up really our events, our signals. So I'm going to call our update display fancy method every time we get a new value from our, here we go, that's going on, from our sensor, from our BMP180. So I'm going to put this in here, and we're going to grab that new temperature value and pass that in. And also on button change, I'm going to have a little bit of fun here, and I'm going to toggle our isMetric boolean. And let's just build this and make sure I've got everything working. I think we're in pretty good shape here. All right, so fingers crossed. Let's deploy this and let's see what we've got. And we'll give this one quick moment to deploy. And of course, our board here today is being powered over USB, right from our PC. And we can, of course, hook up an external battery. Aha, and there we go. I think this is upside down. I'm going to try and turn this around for you. So see if my cable's long enough. If we can get that to focus nicely. There it goes. Actually, it's super bright on this camera. It's actually, I might have to post a screenshot later or put it on Instagram. It's actually really nice colors off the Wilderness Labs website. And it's just the way it's picking up those colors. But pretty fantastic. So notice we're reading in temperature data. And again, I'm going to put my finger on the sensor. It's going to warm up a little bit. Yeah, it's responding to that. And again, we're reading Fahrenheit. Let's switch that over to Celsius. And there we go. Apparently it's a little bit warm in my office today. Now, let's see, it might be a little bit tiny, but if you look down at the bottom, there's actually a small value that's showing the local pressure here too in millimeters Hg, and then it's actually updating as well. So think about that. In half an hour, we hooked up a display, an atmospheric sensor reading temperature and pressure, and we have some user input from our buttons. And we did this all in, what, less than 200 lines of code, I think. A lot of this is old code we can take out. So again, this really allows for rapid prototyping. I'm going to hook up something else, just a quick demo to show some other things you can build. But while it's booting up, I want to hop over to GitHub and the Wilderness Labs website and show you just a little bit more about Meadow Foundation. So let that boot up. So over on the Wilderness Labs website, we actually have really great documentation on Meadow Foundation. And this gives you a bit of a sense of the scope of drivers that you see on here. I think there's over 100 drivers available today. There's a number of other ones that are in development that are open source. And we're adding new drivers almost every week. A lot of great work done by the folks at Wilderness Labs. And a lot of it done by folks like you. A lot of people have been contributing either fixes or new drivers. So I'll say this, thank you very, very much. And we're going to see is this driver surface is going to grow and grow and grow. And let's see here. So I'm going to just do a quick pull around. Here's a fun one. I love this one. For example, we've got a radio. This is actually a bit of hardware that allows you to tune in FM radio stations. And actually, you may, if you were watching Scott Hanselman demoed this for .NET Conf last year. Showed that on a Meadow board. Lots of display drivers. We have things like piezos. You can make, you can actually play music and expect at Christmas time. I'm sure we'll do something with Christmas carols and such. We've got EEPROMs. We can actually store data to EEPROMs. You're going to see a demo later. But Bryn, who's going to show you how to use wireless transceivers to transmit data. I'm really excited to see that. Motor controllers, relays, real-time clocks, and a lot of these basic building blocks. See some camera drivers as well. We've got a whole bunch of new ones coming in there. GPS is coming soon. Lots of motion sensors. These are lots of fun. Accelerometers, actually even 6 and 9 axis accelerometers. They can detect rotation, gravity, and such. I could go on, but what I really want to show you here, and I'm actually going to click through one of these guys if it gets to where I want to go. So I mentioned these are all open source. Actually, yeah, this is a much better way of seeing the FM radio. It's a cool little guy. And this also, if I recall correctly, uses the I2C bus, so very similar to our BMP. I'm going to scroll down and verify that. Yeah, there it is, pin D08 and D07. So you almost know how to use this radio controller, this radio hardware, just by watching this quick demo. And I'll pop over to GitHub now, because I want to show you this is all open source. So Wilderness Labs, Meadow Foundation. And there's some cool things here. This went right to the radio folder, and typically we'll include the data sheet if it's available. So that big long doc that you probably don't want to read, well, sometimes you need to dig into it to get details, or you want to extend the driver. We do include that there. We have driver, and we like to include samples as well. And so there's some fun ones, and I realize that I've also got my gamer in the background, which is probably a little bit distracting, so we'll come back to that. But I just wanted to really get across that Meadow Foundation is all open source. You are welcome to come in. We love pull requests. I can see there's 6 of them here. I should take a look at that and see if we can't close a few of those. Usually means some pretty fantastic contributions. And keep in mind that we'll be constantly adding new drivers. So take a look on the website. If there's a piece of hardware we want to use, if it's published, there'll be a Nuget package. If it's not, it might be in development, and you might be able to hop onto Wilderness Labs and do a little work and help accelerate that development. Now, I'm looking at my camera, and it looks like there's a little bit of flicker on this, but it's actually this display. This is a really cool one. It's an OLED display. It's actually really bright in person. It's got a very retro, bright lime green feel. And this is another fun example where there's actually a working Tetris game. And again, this is just regular old C#, and I think, if I remember correctly, this sample is available on the website. So I'm going to Wilderness Labs, and if you go into the Meadow samples, and this one I believe is in Meadow Foundation, if I recall correctly, and here it is Tetris. And this is, again, really cool. I'm going to jump into the actual core logic. You can dig through, but the Tetris game is, no surprises here, regular old C#. And I think the whole game engine here is, again, a couple hundred lines of code. And so this code here, you could absolutely pull this off and bring it into another .NET platform. You could turn this into a WPF app, a Xamarin app. You could use it for a Blazor app. It's .NET. You could wrap that up in a .NET Standard library and share it all over the place. So pretty fantastic. So I hope you've had a good time. I had a great time demoing this to you, and I hope you're inspired, excited to build hardware solutions with Meadow and Meadow Foundation. Again, open source, definitely contribute, and prototype, play with it. It's low voltage hardware. This is a great way to learn electronics and build cool things. And I'll make sure that this code is uploaded. I'll actually put it right here in the Meadow samples folder so you can access it as well after the session. And thank you very much. Definitely stick around for more Wilderness Lab DevCamp, and don't hesitate to put questions into the chat. Thank you very much.